All right, let's jump right in. Today, we're taking a deep dive into the future of manufacturing by looking at a piece of tech that tons of us see every single day, but we probably don't think about how it's actually put together.
That's right, we're talking about electric cars. And while we're all amazed by the quick acceleration and the silent ride, the real story, the game-changing revolution, is happening way before the rubber ever hits the road. It's happening on the factory floor.
So why is this such a big deal? Well, to get it, we have to understand that this isn't just about building a new kind of car. It's about creating an entirely new ecosystem from the ground up.
Think about it like this. On one side, you have the electric vehicle, the EV. That's the product, right? The car itself. But on the other side, you have this much bigger idea, e-mobility. That's the whole shebang. The car, the charging stations, the solar panels powering those stations, all of it. And here's the key. You can't build the car without thinking about that entire system.
And to make things even more interesting, EV isn't just one thing. You've got your all-in battery electrics, or BEVs, then there are plug-in hybrids, which have a gas engine as a backup, and of course the standard hybrids. Every single one of these needs a different manufacturing recipe, which just adds another layer of complexity to this whole puzzle.
Okay, so knowing all that, what does it actually take to build these things? To find out, let's get our virtual hard hats on and head inside the factory.
And this quote right here just nails it. We're not talking about just tweaking a few things on an old assembly line. This is a complete teardown and rebuild. You can't just stop making engines and start making batteries. The entire philosophy of how a factory works has to change.
So, what does that change look like? It really breaks down into three huge shifts. First, the tech. You're bringing in brand new robotics, crazy amounts of automation, even 3D printing. Second, your supply chain gets a total makeover. You're not calling up your piston supplier anymore, you're building relationships with battery makers. And third, and this is so important, the people. The workforce has to learn a whole new set of skills for these very specialized jobs. Now, I know what you're thinking. This sounds incredibly difficult and super expensive. So, why is every major automaker pouring billions of dollars into it? Well, because the payoff is absolutely massive. Let's look at the advantages.
First up, material costs. See, to get the best possible range, EVs have to be lightweight. That means using a lot of materials like aluminum. But here's the cool part. Next-gen manufacturing techniques create way less waste. So you end up with a lighter car, and you use less raw material to make it. That is a huge win-win.
Advantage number two, the production line itself gets way more efficient. A gas engine has thousands of parts. An electric motor? Not so much. That simplicity means you can bring in more automation. Robots can do the heavy lifting with a level of precision and speed that's just mind-blowing, streamlining the whole process.
And the third big one is energy. It just takes less energy to build an electric car. You're not casting these giant heavy engine blocks or putting together super complex exhaust systems. All those steps are gone, which means a smaller energy bill and a smaller carbon footprint for the factory.
And get this, the savings don't stop when the car leaves the factory. Here's a crazy stat for you. A traditional gas car has about 2,000 moving parts in its drivetrain. An EV has about 20. That means way less can go wrong, way less maintenance, and, as you can see here, a much lower cost to own it over its entire life.
That difference, 2,000 parts versus 20, that's everything. That's the core of it. So let's zoom in a little closer. Let's pop the hood, so to speak, and check out the next-gen parts that make this all work.
Okay, first up, all the housings and covers for the electronics. Most of these are made from aluminum. So why aluminum? Well, for two really important reasons. One, it's strong but light, which is crucial for getting good range. And two, it's fantastic at getting rid of heat, which keeps all that powerful electronics running cool.
But of course, the absolute heart of an EV is its battery, and protecting that battery is job number one. The battery housing is an incredible piece of engineering. It has to be strong enough to survive a major crash, but it also has to be light, and it usually has these super complex cooling systems built right into it to keep the battery happy.
And the whole skeleton of the car, the chassis and all the support beams, it's all been completely rethought. It has to do two jobs at once, be incredibly rigid to protect everyone inside, and also support the massive weight of that battery pack, all while being as light as it possibly can be. It's a tough balancing act. So, to pull off that high-strength, low-weight magic, manufacturers are turning to some seriously cool materials. This one is a great example. Carbon fiber reinforced plastic, or CFRP. This stuff is stronger than steel, but it weighs a tiny fraction of it. Using it for things like body panels means better efficiency and more miles on a single charge. All right, so let's zoom back out one last time. We've seen the new system, we've walked through the new factory, and we've looked at the new parts. So what does it all add up to for the future?
And here it is. This is the big idea. What's happening in the auto industry isn't just about cars. This intense focus on automation, on lightweight materials, on totally new supply chains, it's creating a roadmap, a blueprint that could change how we make pretty much everything.
All the lessons being learned right now building these incredible electric vehicles, they're not going to stay in the auto industry. They're going to spread. This revolution didn't end with the car. It just started there. So the real question is, what's next?